Okay, guys, up to this point, we have talked about ratios, we've talked about rates. Now what we're going to do is we're going to talk about what happens when two sets of ratios are equivalent to each other. So basically, what we're doing is today we're talking about something called proportional and non-proportional relationships. All right, so here we go. The very first word. So if you actually don't have your notes out already, make sure you have green on the left, notes on the right. Green on the left, notes on the right. We have three words that we're going to talk about today. The very first one is called proportional, everyone. Okay, so here's what we've got. When it comes to proportional, your book says this is the ratios when the ratios of related items are equal. So proportional, AL, suffix being an adjective, describing when two ratios, okay, it says of related items are equal. All right, so here is where you can write down in your box, equivalent fractions. Okay, now I know that, remember, ratios are not fractions, but they can be written in fraction form. So when you have two ratios that are, if this is a 1-to-2 ratio and a 2-to-4 ratio, these aren't really called equivalent fractions because they're ratios, not fractions. But if they are equal to each other or equivalent, they're said that they're not equivalent. They're said that they are proportional to each other. Okay. Something else you can write in your box is when two things are proportional, they will have the same unit rate. The same unit rate. Okay. Now, things can be proportional or they can be non-proportional, everyone. Okay, so here's what your book says. It says when things are non-proportional, this is a relationship in which two ratios are not equal. Of course, right? Proportional is that they're equal. Non-proportional is that they're not equal. All right, and so if proportional is equal fractions or equivalent fractions, non-proportional means that they are not equivalent fractions. If you want to extend that in your small box off to the right, you could put different. They would have different unit rates. Now, if and only if two ratios are considered proportional, you're going to have something called a constant of proportionality. Everyone? So here's what constant of proportionality is. This is a constant ratio or unit rate of a proportion. So it's basically, here's what a constant of proportionality is. It's a unit rate without the denominator of 1. Okay? Here's a couple other things I want you to add to your notes there. A constant of proportionality is not only a unit rate, but it's a unit rate expressed as y over x. Okay? And then we'll talk about this in a little while, but there is an equation that goes with this lesson that we're going to be using, and it talks about how the constant of proportionality goes into this equation, and we'll talk about this in a bit, but go ahead and write this down. Okay, it is y equals kx. Y is equal to kx. Okay, so with that said, we're going to do some examples together. So what I'd like you guys to do is go ahead and grab your book, grab a piece of paper, name, date, lesson number, of course your book page up at the top. All right, so here's what I'd like you to do. I know this is off of your homework, and I'm going to give you guys time to do it, but here's what I would like you to do is to just, after you get your book out, your paper ready to go, flip over to page 208. But what I want to do is I want to do problem number 4 on page 208. okay, without you having to worry about it. I just want you to watch this first time because there's a lot going on here, so I want to make sure that you're paying attention and watching, okay, and then I'll give you some time to write it down. All right, so when we are looking at number 4, go ahead and read the directions. Okay, so I want to point something out on the directions. All right, it does say there's a number of different things. It says, right? It says determine whether the set of numbers of each table is proportional. That's the first thing you're going to need to do. It says if the relationship is proportional. This is conditional. So if it's not, you don't have to worry about this. But if it is proportional, they want you to identify the constant of proportionality. Okay. Now, the other thing is they want us to explain our reasoning, but that actually you're going to see is going to go with number 1. Okay. So here's what we're going to do. Here we go. Just watch me. The very first thing I'm going to do on this is I'm going to take a look. Now, with this, a lot of times, even though there is no x and no y on a horizontal table like this, a majority of the time, that first factor is your x, and the second one is the y. All right. And so here's what we're going to do. So we have cans of concentrate, cans of water. Concentrate is, let's say, like orange juice, like that frozen chunk of like almost frozen oranges that you can make orange juice with by dumping water into it and mixing it. Okay. So here's what it's talking about. It wants to know if it's proportional. So here's what we're going to do with this one. Is first you're going to see me find the unit rate of all of these. Now, the reason why I'm doing that is, again, if they're all the same, that would say that these two have a proportional relationship. So here we go. We have 4 over 1. Remember, y over x, and the y is the cans of water. So 4 over 1. This one is an 8 over 2, which reduces to 4 over 1. So far, so good. Now, listen, if this was already different, like 5 over 1, I could stop, because that would say that the relationship's not proportional. But so far, so good. I do need to see if this whole thing is proportional, though. So here we go. 12 over 3. Well, reducing that, that's 4 over 1. And this is a 16 over 4. Okay, and the unit rate on that is a 4 over 1, meaning 4 cans of water per can of concentrate. So they're all the same. So on number 1, what I'm going to do is I'm going to put, I'll write a little sentence over here. I'm going to go ahead and put, it is proportional. And it does explain my reasoning. So I'm going to, of course, my explanation, I'm going to use the word because. It is proportional because the unit rates are all equivalent. And I'm going to go ahead and you're going to notice that I'm going to use this explanation on pretty much everything. If it's proportional, it's because the unit rates are all equivalent. I have my work to back it up. There it is. Now, the next thing I'm going to do is it says, if it's proportional, right, identify the constant of proportionality. Okay. Now, in our definition, right, when we were talking about this, it says that a constant of proportionality, okay, is y over x, right? That's what it is. It's a unit rate, y over x, without the denominator of 1. So watch. Y over x is right here. It's our unit rate, y over x. This is already set up without the denominator of 1. So bottom line, ladies and gentlemen, is after you do it, it's that top number. Our constant of proportionality is a 4. And that is what you're going to do in this top section on what these directions tell us to do. Okay? So you're putting your y over x, you're finding the unit rate, see if they match. That tells you if it's proportional or not. And then if it is, you take that top number of your unit rate, and that is your constant of proportionality. And we'll talk about where that comes in just a bit. Okay. With that said, all right, let's go ahead and let's do one more together. But before we do, I'm going to go ahead and give you, you don't have to write, of course, you don't have to copy down the chart, but I do want you to show some work here and then make sure you have the proper answer with an explanation. All right, so I'll give you guys about 1 minute to copy that down. Go. Okay, hopefully you have everything down. Okay, here's the one I want to do together. We're going to write our steps down. This is a little more challenging, all right? And the only difference is that we have to fill out the chart is basically what it is. That's the only thing that's up front that's different than what we just did. So if we take a look, our direction says copy and complete each table. Again, you don't have to copy it. Actually, what I would like you to do, you will have to copy it, but what I want you to do instead of copying the whole thing exactly, we're just going to make it like a sketching of the table. It says determine whether the relationship is proportional. If so, identify the constant of proportionality.
London, Cordova, please come to the Rayburn office. London, Cordova, please come to the Rayburn office.
Okay, so here's what I would like you to write. Go ahead and let's do this. Let's go ahead and put number of rides and the cost, and then put a $sign in money. Okay, and let's go ahead on our paper and we'll go ahead and put this as step one, is just do the table. All right, so we're going to copy it down and then we're going to fill it out. So they want to know how much is it going to cost if we ride 1 ride, 2 rides, 3 rides, 4 rides, and 5 rides. Okay, so on some of these you can use a calculator if you'd like. Okay, so here we go. So I'm going to fill this out. So if it's 1 ride, if you take a look, here's the condition. It says admission to an amusement park is $4 plus $1.50 per ride. And that's of course what this is, the number of rides. Okay, now here's what I want to make sure you know. The $4 here, that word plus, that $4 is one flat fee. Right? You go in, you don't pay $4 for every single ride. It's just going to be $4 to get in the park and then $1.50 every time you want to ride something. All right, so here we go. Let's find out how much it is for 1 ride. So this is what we're going to do. So we have $1.50. We could say we can multiply that by 1, right? Because there's 1 ride, and then you're going to add 4 to it. So what we have is we have $1.50 plus $4, and that is $5.50. So I'm going to put $5.50 for 1 ride. If we were to ride 1 ride, it's $5.50. What is it if we were to ride 2 rides? So it's $1.50 times 2 plus the $4. So $1.50 times 2, right, is $3 plus $4. That's a total of $7. So $7 for 2 rides. We're still doing step 1. We're just filling this out. It's a lot involved. $1.50 times 3 for 3 rides plus $4. So, I mean, realistically, since it's just going up by 1, right, I can multiply this, or I could just be adding an extra $1.50. So before it was $3, this would be $4.50 plus $4, and that is $8.50. So $8.50 for 3 rides. What about 4 rides? So $1.50 times 4 plus the $4. Well, $1.50 times 4, well, $2.50s is $3, right? And 4 of them would be $6. So $6 plus 4 is $10. So that's for how much the whole experience would cost us if we were to ride 4 rides. Or what if we decided to ride 5 rides? So $1.50 times 5 plus 4. Well, $1.50 times 5, okay, is an extra $1.50 off of 6. So it's $7.50 plus an extra $4, which would be $11.50. All right, so we just completed our chart. Okay, now comes step 2, and that is, let's go ahead and find the unit rates. Well, this right here is, and remember, this is our x and y. We want to get in the habit of going ahead and recording it as y over x. So basically what it is I'm going to put the 550 over 1. So it's $5.50 per ride if we were just to ride 1 ride. Okay, let's go ahead and do it to this one. $7 over 2. Remember, unit rate is over 1. So if I divide bottom and top by 2, I get 350 over 1. Ladies and gentlemen, I already have 2 different unit rates. If I ride 1 ride, it ends up being $5.50 per ride. But look at this, the unit rate's not the same. If I ride 2 rides, it's only $3.50 per ride. So guys, this here, I'm going to go ahead and write my sentence. Here's what I'm going to write on this one. It is a little different than this one, the red one up here. Here we go. It is, instead of proportional, they don't match, so it's non-proportional. Because, and this one was proportional because the unit rates are equivalent. This one's it's non-proportional because the unit rates are not equivalent. Now on this one, there is a step 4, but put a little star by it because step 4 is find out the constant of proportionality. Now here's the thing. Is the constant of proportionality 550 or 3? Well, guys, there is no constant of proportionality. They're not the same. Right? Up here, they were all the same. It was 4, 4, 4, 4 over 1. That's why we use 4 as the constant of proportionality. This one changes. They're not constant, so there is no constant proportionality. That's why I put the little star. So there will be one if they're proportional. There will not be one if it's non-proportional. Okay? Okay, so here's what I would like you to do, is go ahead and I want you to try out problem number 10. Problem number 10. Go. Okay, 30 seconds. Go ahead and turn to your neighbor and share. Please, when they share, make sure that if it's proportional, they have the explanation along with the constant proportionality. If it's not proportional, make sure that they have the explanation. Of course, there should be no constant proportionality. Okay, so 30 seconds. Go. Okay, here we go. It says Miss Rollins had an end-of-the-year party, pizza party for the chess team. At the party, every 2 students had 5 slices of pizza. All right. So, in this particular case, I'm going to go ahead. Hopefully, you drew your chart. Okay. To save time, I'm going to just use this one that they have here for me. All right. I'm going to go ahead and do exactly that. I'm going to fill out my table. So, it says here's the number of students, which is your X. And then your Y is the slices of pizza for those students. So, if there's 2 students, it says they have 5 slices of pizza. Well, that one's easy right there. 2 is 5. Okay? In this case, look at that's double the students, so they would have to have double the slices of pizza. Now, if you don't believe me, watch. If there's 2, there's 5 slices. Here's an extra 2 people, another 5 slices. Look at, there's 6. So 2, 4, 6 students. There's another 5 slices, which means it's 15. Another 2. There's another, so 2, 4, 6, 8 students. There's a total of 20 slices. And you add on another 2 students, another 5 slices, so we have 25 slices. Okay? Our unit rate, guys, is, well, in this case, 5 over 2 is not a unit rate, right? The bottom number has to be 1. We divide both top and bottom by 2. You should have had 2.5 over 1. 10 over 4. To get 1 on the bottom, divide both top and bottom by 4. And using your calculator, you should have got 2.5 over 1. 15 over 6. Divide both top and bottom by 6. And get 2.5 over 1. 20 over 8. Divide both top and bottom by 8. And get 2.5 over 1, and it's looking good. So now we have 25 over 10, and that comes out to 2.5 over 1. All the same unit rates. So I need to say, is it proportional? The answer is yes. So I'm going to go ahead and write this right up here. I will put, it is proportional. They ask for the explanation. So, because the unit rates are the same. And then it does ask, look at, identify the constant of proportionality. Remember what that is. Here's your unit rate. The constant of proportionality is on the top. It is 2.5. Okay. Now, here's what I'd like to do. Before we do this second kind of problem, I want to talk really quickly. Let's take a break. You can put your pencils down. I want to talk about the constant of proportionality. Okay? Constant of proportionality. Remember, constant of proportionality is y over x. Now, you're in math land, right? In a lot of mathematicians, they will give this a symbol or a variable, and that is k. Constant proportionality is represented by a k. Now, listen, the way we write it, right? We talked about this, is you put it in the unit rate, y over x, and then you turn around, and it ends up reducing, right, in the unit rate, and you just take the top number. So this is the form a constant of proportionality, they also use the letter K. So here it is safe to say if this is constant of proportionality and so is that, we can say y over x is equal to K. Now what I want to do is really quickly I want to go ahead and take you back to 5th and 6th grade in a one-step equation. So here's what I'm talking about. Okay, what if we had something like x over 2 is equal to 6? Now, the way you would solve this problem, right, is you would say, okay, well, here's the x. I want to get it by itself, meaning I want to isolate the variable. And what you'd want to do is you'd want to do the inverse operation to get rid of this 2, okay, because that's the whole point of getting it by itself. Well, the inverse operation, or the opposite of the operation of division, is multiplication. So here's what we do. We multiply this side by 2. Excuse me. Now, with equations, it's almost like having to be fair. Whatever you do to one side, you need to do to the other to keep it equal to each other. So when we do the opposite here, those cancel. We end up with x, and then right here you'd say 6 times 2 is 12, and you'd have your answer. Now, what I want to do is just because we have a bunch of letters over here, or variables, doesn't mean that we would treat it any different than we do over here. So watch. Let's say I wanted to get y by itself, just like I wanted to get this top number here, the x. Well, to be able to get rid of this x, I have to do the opposite. So if it's y divided by x, I would multiply by x, just like I multiplied by 2 here. Now, of course, like the 2's cancel, the x's cancel here. Then, to be fair though, just like we multiplied the other side by 2, we have to multiply on this one, the other side, by x. And so here's what we have. On this side we have y. On this side we have k times x. Now we don't get a nice simple answer like that, right? So here's all we do. Kx. Now here's the whole reason why I'm telling you this. I am showing you where the constant of proportionality equation comes from. So it's y equals kx. The constant of proportionality, which of course is the k, can always be plugged right in here to create your equation. K is the relationship between x and y. Okay, so I'm going to use this equation in these upcoming problems. All right, so let's go ahead and let's take a look. And you keep your pencils down just for a second here. Let's take a look at problem number 8. I'm sorry, problem number 3. Problem number 3. Okay, now the only challenging part here, and I'm going to help you out with this, is when you find out, it says, well, let's read it first. It says the cost of 13 gallons of gasoline is $41.47. Find the constant of proportionality, which is the first thing we're going to do, and then write an equation, second thing, relating the cost to the number of gallons of gasoline. How much does 18.5 gallons of gasoline cost? Well, they're asking us to do a third thing. Okay, and believe me, just pencils down. I will give you time to write this down. Okay, here we go. The first thing you want to know is that there is no chart here, so it can get a little confusing, but you don't find out how many gallons you get for $1 when you look at the prices of gasoline. It's how much money there is per gallon of gas. Okay, so with that said, this is going to be your y. This is going to be your x, the amount of gallons and the price. Okay. Now, we're going to talk about that in the future, but here's all you need to know. When we set this up, we're going to set up y over x. So what that means is this is step 1, is I'm going to go ahead and find my rate. It is $41.47 to 13 gallons. Here's my y, here's my x. Now what I'm going to then do is I'm going to go ahead and do step 2, which is I'm going to find my unit rate. It's already set up as y over x, so that means my gallons are on the bottom. Per gallon is 1. So I'm going to divide both top and bottom by 13. So get the calculator. 41.47 divided by 13 equals it ends up being $3.19 per gallon of gas. Now, the reason why we had to do all that is to do step 3, which is the first part of our answer, and that is we needed to find the constant of proportionality. Since this is already y over x, remember what I told you guys, constant of proportionality is the unit rate with just the top number. Our constant of proportionality is 3.19. Okay, that's our first answer. Then it says, then write an equation relating cost to the number of gallons of gasoline. So watch this. This can be considered step 3, and that is I'm going to write an equation. Now, don't forget, in our notes, we had an equation is y equals kx. Remember, k is our constant of proportionality. So watch how easy this is. Instead of putting y equals kx, I'm going to put y is equal to the constant of proportionality in this problem, 3.19x. Now, here is what I want to just share with you just briefly because we're not done with this problem. But think about it. If x is the number of gallons of gas, if it was 1 gallon, you'd say 1 times 319, which would be 319, which is how much it would cost for 1 gallon of gas. If x was 2 gallons of gas, and I multiply it with 319, that's going to give me the price of my gas here. The price is my y. Of course, that's what I said over here. So this is fantastic. That is an equation we can use for this. So here's what we're going to do next. Okay, and this is step 4. We're going to use our equation. So we have an equation. Now we're going to use it. You say, well, what do you mean, Mr. Wilkins? Well, here we go. How much does 18.5 gallons of gasoline cost? That is saying 18.5 gallons. The x, remember, is the gallons. The x is the gallons. So I'm going to go ahead and plug in 18.5 for x. So what that means is when I multiply these two together, it's going to give me my price. So 18.5 times 3.19 equals 59.015. I'm rounding to the nearest cent, which is the nearest hundredths. The 5 makes the 1 go up. So what we have is $59.02. So ladies and gentlemen, this is a 3-part answer. 3.19 is our constant of proportionality. Our equation is y is equal to 3.19x. And then our price for the 18.5 gallons is $59.02. Okay. So, I do want to do one more with you guys, and that is problem number 8. Okay, problem number 8. Before we get to number 8, though, I'm going to go ahead and do what I promised. I want you to go ahead, write down your rate, your unit rate, write down the steps. So I'm going to give you guys a couple minutes to do this, and then write down your 3 different answers. 2 minutes, go. Okay. So those of you that finished early, hopefully you were working on some of the other problems. Let's take a look at number 8 really quickly. Okay, it says financial literacy. It says a store is having a sale where all jeans are 1/4 off the regular price. Find the constant of proportionality, then write an equation relating the sale price to the regular price. Okay, so here's what I'm going to do. I'm going to kind of walk you through this a little bit. First off, all right, it says a store's having a sale where all the jeans are 1/4 off the regular price. Now, if I was to build a chart, okay, we would have the regular price, and we would have the sale price. Okay, now I want to talk about this really briefly here. Okay, you have to remember 1/4 off. Now, we haven't talked about percents yet, and when we get into percents, we'll talk more about this. But you have to remember something. Let's say this whole, just a little diagram here. This whole thing, let's say, was the regular price of something. You have two sections that make up the regular price if that item is on sale. Okay, you have the discount, which is the amount that's coming off of the price, and you have the sale price. So let's say, I don't know, a price of jeans was $10, and it was on the discount was $3. Well, if the regular price is $10, which is this whole thing here, the discount is $3. That means that the sale price is $7. Now, the same thing could be said about fractions. If, let's say, the discount was 1/4, meaning the 1/4 off, the sales price would be 3/4 of the regular price. Okay? So what that means is, and what we're going to do is we're going to put this as 0.75. So here's what we have. Okay? The regular price is going to be X. The sale price is going to be Y. Now, if the regular price, okay, is, let's say, let's make it easy on ourselves, $10. Okay? The sales price would be 75.75 times 10, which is, of course, $7.50. Okay? So, what we have is main point is we're taking the regular price and multiplying it with this. So what we have here is this is our constant of proportionality. So we have, if this is X and this is Y, here's what we have. Y is equal to, because we multiplied it, right, with 75/100ths X. So when it says find the constant of proportionality, there it is. It says then write an equation relating the sale price to the regular price, which is what we did, sorry. So we have our constant of proportion, I was getting ahead of myself, constant of proportionality. And if you didn't believe me, you could have went the other way, right? You could have had your Y, 750, over your X, which is 10. If you get that to 1, you end up with 0.75 over 1. So there's your constant of proportionality. Okay, like I said, plug that in. And then it goes on to say, how much would a pair of $29 jeans cost on sale? So, if I use my equation, Y is equal to 75/100ths X, I plug in $29. I'm going to go ahead and get what that would be. So 0.75 times 29 equals 21.75. And of course, put our dollar sign on that. Okay. I wanted to make sure I did number 8 with you because most of the other ones will be easier, like number 3 that we did before. Okay. So I wanted to do that with you because of this little twist to it up front. All right. Okay. So a little lesson on proportional and non-proportional relationships.